So in your lab, you notice that if you mix certain liquids together, that they can actually become cloudy or change color and form what we call precipitate. And a precipitate means that you've got little flakes of solid that are floating in there, and that's why it's cloudy. That cloudiness are those little flakes of white mixed in with the water. And of course, we want to show that what's going on in a chemical reaction, as a chemical reaction in a chemical equation. And we call those precipitation equations because they form a precipitate. And there are certain strategies of how to go about it. So let's say I'll give you one example of the one that we've used, sodium hydroxide mixing with silver nitrate. And you notice that it did actually become cloudy. So how would you actually show that in a chemical reaction? Well, the first step is this. The first step is that you want to actually write it as reactants together. So we know that all of these are aqueous. So we simply write NaOH with aqueous sign combines with AgNO3. So we'll write just a note to ourselves, write reactants with the term aqueous. And this is always going to be the case. They'll always be aqueous. All right, so the next step is as we know with anything that is aqueous, it means that it's been dissolved in water. So if I were to give you a visual image of that, here's my beaker. This is what we've been doing in the last weeks, is that you have here water and you have a sodium ion that has separated from an OH ion, okay? Now, how do you know that it was the sodium and the OH as opposed to just an O and an H? We also have silver that's separated from an NO3. This is a plus as well. And we'll do one more over here. And an OH over here. So these were all put into water, and they have more or less disassociated themselves from each other and are now in the form of cations and anions, okay? So that's how we know, because anything that's aqueous will separate itself if it's an ionic compound to the cations and anions. So the next step is we want to actually write that in an equation. So we want to write what we see here in an equation. So the first thing that I like to do is use the polyatomic chart. Okay, Na I know is a cation, and with the periodic table or the polyatomic chart, I know that that is an AQ, an Na with a plus. That's in the first column. The next one is an anion. I can figure that out using my polyatomic chart. That's AQ as well. The next one, Ag, is a +1. Thanks to my polyatomic chart, that is a cation. And then I have NO3, which is a negative charge. That's AQ as well. Okay, so what I've done is essentially have shown that they've all disassociated in that water to be separate cations and anions. Remember, you're separating them by cations and anions, and you use that polyatomic chart to help you out. All right, so the next thing that happens is that this one here we know is a precipitate. So we're going to continue on with what that equation is. So one of these is going to actually form, one cation is going to combine with an anion to form a solid. And here's how it works. Essentially, these two, the cations, they swap, okay? So the Na goes over here, the Ag goes over there. They recombined, okay? So we're going to write that down as a possible reactant. So in this case, we could have NaNO3. Make sure your charges work out to be 0. Remember, we know that this is a plus charge, this is a minus charge, so that works out to be 0. We don't have to put any subscripts on there. So that could be a possibility of a solid, that this one became a solid. That means that the other ones did not. Okay, so we'll just keep those as they were originally. So that's option 1, okay? Or it could be that Ag and OH combine to form a solid, and the other ones stay as is. It is only one of these that will actually form into a solid. The others will stay in aqueous form. Okay, so let me just review what I did. I essentially swapped these. So see how I put the Na in front of the NO3? And I am assuming maybe that became the solid. I keep the other ones exactly as I wrote up here. The next one is that I could swap is making the Ag go over here to be AgOH. That could be the solid, Na and NO3. So now how do I know which one is in fact the solid? Which one of these is right? So on page 450 in your book, there are some solubility rules. You're going to see what they are. And one of the solubility rules says that any ionic compound containing group 1 or ammonium cations are soluble, okay? So this is something that is in group 1, okay? So it's telling me that it is soluble. That means it cannot become a solid. It tells me, so this cannot become a solid. We know that this is not an option, okay? So we'll cross this one out. So let's see whether or not it tells us whether or not this can be a solid. It tells us also the next one, anything with a nitrate.
Good morning, St. Mark Cathedral. Please join us for morning prayer in the chapel beginning at 7:40. All students, faculty, and staff are welcome. Thank you.
The second rule was anything that has a nitrate is going to be soluble. So again, here we not only have something in group 1, but it also has a nitrate. Those are soluble. It cannot become a solid. The third rule on page 450 says that anything containing chloride, bromine, iodine ions tend to be soluble unless they're combined with silver, okay? So in this case, we have silver combining, so it's not soluble, all right? It also tells me that ionic compounds containing carbonate, phosphate, or hydroxides tend to be insoluble unless they're with ammonium or 1. So this one here, based on the fourth bullet point, that rule says that silver cannot be, that hydroxides are not soluble. So this is our right answer. So let's rewrite it to be Na plus aqueous plus OH minus aqueous plus Ag plus aqueous plus NO3 minus aqueous to AgOH solid plus Na plus, and I should include aqueous here too, aqueous plus NO3 aqueous. Okay, so this is our what we call total ionic equation. Essentially what we're showing is what actually happened, and what did actually happen is that the Ag combined with the OH. Here is an Ag combining with the OH to make a solid. So that's what happened in the beaker. The rest of these did not combine. So this is a lot of writing. So what we also offer is something that's called a net ionic equation, and that's where you kind of take out all the cations and anions that didn't change. So you notice that you have a sodium by itself here, sodium by itself here. We cross those out, and then the nitrate over here is by itself, just like the nitrate there, and we just kind of deal with the ones that did actually make the change. And so it makes no difference what order we have it in. We have silver, and hydroxide forming to AgOH. And make sure you write that solid on there. And we call this the net ionic equation. So why is this important? Well, especially with our water unit that we're going to be working with, we can see whether or not there is some substance of it based on if it makes a precipitate. So if we want to see, okay, is there silver in this water? And silver is not maybe necessarily something you want to have in water. What that means is that we can add sodium hydroxide in there to actually see whether or not it forms a solid. If it does, then we know that silver's in there. So your work is going to be that I'm going to have you read C2 and C3, and I'd like you to try the problems. I'm looking for in class that you've at least attempted them, used the video, have reviewed them, and so that you can, when we meet next time, we can work through them together and just fine-tune the skill. All right, thank you.